Hello everyone and welcome to my YouTube channel. My name is Brian. Today I'm going to take you through the different techniques of creating an artificial intelligence project, the different challenges you may face while creating this model, how to overcome such challenges, the data to be used, and so much more. So let's jump right into it. So I'm going to first give you a brief introduction of our project. This project applies in the human resource field, which deals with recruiting of people for different jobs in different companies. So it can be tedious when it comes to recruiting people since many people apply for the same job. They can be hundreds and even thousands of people. So it makes it hard to scan through their resume to identify the best candidate. So by building this model, which can skim through a candidate's application to identify the different keywords which are required in a resume, the different skills, and another thing, it identifies the different unwanted words such that it eliminates such candidates, and this makes it easier for the recruiters to identify the best candidate and also for the company to maximize expertise since best candidates can be chosen for the job. So for this project, we are going to use natural language processing, which is a subdomain of artificial intelligence, which deals with uh, natural language, which deals with human language such as English. So this model is fed with information. For example, for our case, uh, we can feed it with the different resume information, which contain the different skills required for a candidate. Then it skims through those skills, it matches them, then it removes the unwanted words and everything such that it identifies the best candidate. As we said earlier, it utilizes natural language processing subdomain of AI, which mimics the language used by people to communicate and finds the different common patterns of how the language flows, the different keywords, the word flow and combinations. And as we said, English is one of the natural languages which people use to communicate. Uh, so for this project, we are going to be using the dataset which is can be found at Kaggle, which is basically a data science website, data science company, which has a lot of data sets to be used in different projects for machine learning, data science, big data, and everything. And we're going to be also using the natural language toolkit for Python, uh, which is just a model for clustering different data categories, categorizes data together, the different data which is similar together. Then it gives scores, weight scores to the different categories. For example, in our case, if a resume has a lot of keywords which the company requires, to give it a score of 10, whereas those with low keywords offer or a lot of unwanted words to give it a score of 0. So we are going to look at the differences between supervised and unsupervised learning, how we can utilize such techniques in our project. So in supervised learning, it just basically means that we have the input, it's already known, and you already know the output also. So uh, it can be thought as a teacher supervising the learning process. So in this kind of algorithm, the possible outcome, which is the output, or the features are already known, and the training data is also labeled with correct answers. So we already know the input and output. So for unsupervised learning, we don't know either of the two. We don't know so we may be knowing the input, but we don't know the output. So these kinds of machine learning algorithms do not have any supervisor to provide any sort of guidance. In other words, unsupervised learning, there will be no correct answer and no teacher for guidance. So this algorithm, it discovers the different patterns in the provided data by itself, then it identifies the different rules and makes decisions for itself. So the different techniques for supervised learning that can be applied in our project, we have classification, Classification, mostly it refers to categorizing uh, categorizing the different output together. Uh, so a problem is called classification problem when you have categorized output or labels. So for instance, in our resume parser, the output can be a set of accepted keywords or unwanted keywords, such as skills that are essential in any resume. And for the unwanted words can be slang, vulgar, and everything. Then for the regression, the problem is called regression problem when you have the real value output. For instance, in resume parser, certain company may be interested in specific skills that a candidate can possess, and this may only apply to that company. And some of the skills can be DevOps, Docker, and Kubernetes. So for classification, we know the we know the output is general, it's categorized. Then for regression, it is a specific output. So it's specific, it applies to a specific company. Then for classification, it's general. Uh, then for unsupervised learning, we look at techniques such as clustering. So in clustering problems, we need to discover the uh, inherent groupings in data. For example, grouping similar words together in a region parser. Then association, a problem is called association uh, problem because such kind of problem require discovering the rules that require large portions of data. For example, in our region parser, we have lots of keywords to identify. So basing on those keywords, the model defines certain rules on how to categorize this data based on the keywords, similarities, and unwanted keywords, uh, as we said, such as slang and vulgar and so on. So when you're developing any model, there are always challenges that come along the way. So some of the possible challenges that we may face in our project, for example, we know that different companies require different skills and they look at a lot of stuff. So using just one single data set may not give us a correct measure of how to categorize these regions because it generalizes everything. So using a general data set to train the model may make it to be biased towards some candidates. So another issue is this model may not be efficient enough if it looks for the only keywords required in a resume, since most candidates may study most of the keywords and apply them in their resume. So selecting a best candidate may be hard. So some candidates already know about these techniques which they use, so they study all the keywords which are required and they make sure to maximize them in their resume. So it makes it hard for the model to select the best candidate. So another challenge is for when you look at efficiency and accuracy, the model requires massive amounts of data, which may not be provided since the data set we use can not cover every field and every domain in each company. So it may be hard to maximize efficiency and accuracy. So the possible solutions to the problems, these are the possible solutions. So to eliminate bias in this model, various datasets with various skills required in resume from different domains should be used to train the model. So we can get datasets from different fields with a lot of data, not only looking at one domain. So we get a lot of data from different fields, then we feed it to a model and train it. So to maximize the efficiency of the model, the dataset provided should not only include required words, but also the unwanted keywords such as slang and vulgar. Because if we look at only a data set with only required keywords, where we're looking for only required keywords, and most candidates know about the keywords and have put them there, so it's very hard to identify. But if we provide also unwanted keywords for identifying unwanted keywords, so it makes it quicker for the model to find such words and immediately disqualify the candidate. So for higher accuracy, huge amounts of data uh, should be used to train the model, and this can level up on how accurate the model finds the best candidate for the job. Uh, so we are going to look at the different terms And these are the different evaluation matrices that are used in AI. We have accuracy. So accuracy, just basically the number of correct predictions made by the model uh, over all the kinds of prediction. So it's just a quotient of prediction over kinds of prediction, over all kinds, the correct ones over all the kinds of predictions that were made. So precision just explains how many of the correctly predicted cases actually turned out positive. Recall, yeah, defined as how many of the positives do the model return? That is to say the actual positive cases that were predicted correctly by the model. So F1 score, it's just a combination of the precision and recall matrices. It is maximum when precision is equal to recall. Um, so for any project, we have to have the evaluations in the the evaluation matrices for every project that you do. So we are going to look at the confusion matrix, the confusion matrix, uh, which is basically for classifying problems where the output can be of two or more types of classes. It is the easiest way to measure the performance of a classifier. The confusion matrix is basically a table with two dimensions, namely actual and predicted. Both dimensions have true positives, true negatives, false positive, false and false negative. So for example, we may have here a table of 4 columns. So we have here for true, we have 1. For false, we have 0. For positive, we have 1. For negative, we have 0. So in this first row of the first column, so we have this first column of the first row, we have this is true and this is positive. We have true, positive, positive. So here this is true, this is negative. We have true, negative, and this is false. We have false, positive, and also we have false, negative. So this is basically a table which I'm talking about. So another metric is accuracy. So accuracy is just the number of correct prediction made by the model over all the kind of predictions made. For instance, in our model, accuracy would be the number of correct keywords matched or the unwanted keywords identified in a resume over all the keywords in the resume. So that's basically it. So here we come to the end of our the different techniques we're going to use. We come to the end of our project. So for the different references, we used some from we used the for the different matrices we got from this link. Then the project was I got inspired from this website, which has a lot of projects for beginners and advanced, also intermediate level. So you can visit this website to identify the different machine learning, data science, or just artificial intelligence projects that you can build and include in your portfolio. So thank you very much for listening, and I'll see you next time. Thank you. Bye.